Okay, welcome back, guys. So one of the questions that I know has been vexing a lot of you guys is, what's going on with that c? Is there ever a time that we can solve for that c and figure out a number for what that c is? And the answer to that, of course, is yes. So here's the idea. If you have an initial condition, you can actually solve for c. Now, this is very exciting, of course. So what this will look like is you'll have a problem where they give you like some derivative. So they tell you that f prime of x is equal to 4x cubed. And they give you one value of f, so f of 2 equals 8. This is what's called an initial condition. So it's basically saying that the point 2, 8 is on your graph of f. And then what they're going to ask you to do is to find the function f, find f of x. Okay, so they give you the derivative, they ask you about the original function. So that means that you're going to start this problem by saying your function is the integral, the antiderivative of the derivative. That's how you get your function. So in this case, it would be the antiderivative of 4x cubed. Now, hopefully you've been paying attention at some point, so you know that the antiderivative, okay, what is the derivative of 4x cubed? That's x to the fourth. Now, here's the idea. Once we get to this point, this is saying your f of x equals x to the 4. What you're going to do is you're going to plug in that point. You're going to plug in that point 2, 8. This is your x, this is your f. And then use that to solve for c. So when x is 2, f is 8. So that's saying 8 equals 2 to the 4th power plus c. So that's saying 8 equals 16 plus c. So c is negative 8. Okay, so the only thing here, we're not just asking you to find the c value. We want to actually rewrite the f now using that c value, so we'll plug that in. So my function here is x to the 4th minus 8. Okay, cool, so that's how that works. The next example, let's take a look at one here. So let's say now we have, again, your dy dx equals root x times 1 plus 2 over x. They tell you that y of 1 is equal to 2, and they ask you to find an equation for y. Okay, now, if you feel pretty good about the first example, feel free to pause for a minute and give this a try on your own, see if you can kind of figure that out. Okay, so anyway, y is the antiderivative of its derivative, right? We take the antiderivative of dy dx. So it's the antiderivative of rad x times 1 plus 2 over x. Now, what we want to do in this situation is distribute. So we have rad x and then plus 2 rad x over x. So let's simplify, clean this up a little bit. So that's x to the 1/2. That root x over x, that's x to the 1/2 over x to the 1. So when I subtract 1/2 minus 1 is negative 1/2. Okay, so working from here, let's see. So that's going to be x to the 3/2 with a 2/3 in front. Pretty thankful I have to plug in a 1. And then that'll be 2. So I have x to the negative 1/2 plus 1 is 1/2. And I balance with another 2 in front of that. So just leave the 2 in front and then just put another 2 in there. Okay. So now let's plug in. So they told me right here, the point here was 1, 2. So we'll plug in 1, 2. Okay. So 2 equals 2/3 times 1 to any power is 1 plus 4, 1 to any power is 1 plus c. Okay. So that's saying 2 equals, so 4 is 12/3, so 14/3 plus c. So my c would be negative 8/3 right there. Okay, and then let's go ahead and finally rewrite this. So y is 2/3 x to the 3/2 plus 4 square root x minus 8/3, like that. Okay, so that's how you'll do these problems and approach these problems. You just integrate like you normally do, and then you just plug in the 1, 2, and that lets you solve for c, in this case where you do have an initial point. Okay, so let's get to do some exciting problems, right? Let's do some ones that have to do with the second derivative. So what if I tell you f double prime of t equals 6t plus 4, and I tell you f prime of 0 is negative 6, and then f of 1 equals 9. So you actually have two initial conditions, right? So you have one for f prime and one for f. Well, let's go up the ladder and think about what we're going to do. But basically our step here is we're going to do the process twice. So if I take the antiderivative of f double prime, that's going to give me f prime. And then if I take the antiderivative of f prime, that's going to give me f. So that's the strategy that I'm going to use here. So if I take the antiderivative, so f prime is going to be the antiderivative of 6t plus 4. So when I do that, I'm going to get f prime equals 3t squared plus 4t plus c. Now I'm going to take a brief pause right here to actually plug in the point. Now, I want to be careful which one I plug in. I have one for f prime and one for f. So I'm going to plug in the f prime point first. So that's 0, negative 6. So negative 6 equals 0 plus 0. Oh, that was pretty nice. Okay, so that tells me that now when I write f prime, I'm going to get f prime equals 3t squared plus 4t minus 6. Now, I'm just going to repeat this process again. So I'm going to repeat to find f. So I just use the f prime condition. I use the 0, negative 6 right there. So now I'm going to use the other one when I'm able to actually get f. So f will be the antiderivative of f prime, so 3t squared plus 4t minus 6. So that'll be t cubed plus 2t squared minus 6t plus c. Okay, so the initial condition here is 1, 9. So when I plug that in, I get 9 equals 1 plus 2 minus 6 plus c. 9 equals negative 3 plus c, so my c is 12. Now, one thing worth noting, right, we integrated twice. We got two separate c's here. These are not necessarily the same. And if that confuses you, you could label them like c1 and c2 with a little subscript. You can name them like c and d or something like that. Anyway, let's go ahead and finish the problem and use that. So when I plug that in, I'm going to just go ahead now and plug that value in. And f is t cubed plus 2t squared minus 6t plus 12. Okay, so that's what I did. I just had to take two antiderivatives and do this twice. One more situation that you might see, and this will be our last example for the day, is if I tell you the second derivative is 12x, and I give you two initial conditions, but both of my initial conditions are in terms of f, not f prime. So that's going to just add a little extra step of work to our plans, but not bad. So f prime, of course, is the antiderivative of f double prime. So you take the antiderivative at 12x, so you'll get a 6x squared plus c. Okay, now, do I have an f prime condition I can plug in? Gosh, no, I don't. So I just have to go one more step now, right? So when I go to my next step, I just have to say, okay, well, my f is the antiderivative of f prime, so I better just take the antiderivative of 6x squared plus c. All right. Now, of course, when I integrate 6x squared, that's 6x cubed over 3, so that's 2x cubed. You might wonder, how do I integrate a c? Well, c is a constant. So if I integrate a constant like 3, we know the the integral of 3 is just 3x plus c. So if I integrate a c, just some constant, I'm going to get cx plus some other constant there. It's just a constant, right? You integrate 3, you get 3x. Integrate 10, you get 10x. So if I integrate c, I'm going to get cx. And now I'll just add a d or some other letter here. Okay, now it appears we're at a bit of an impasse because we have two constants, but what I want to encourage you to do is to plug both of them in separately. So I'm going to have one point where I plug in 0, 4, and I'm going to have another point where I plug in 1, 7. Okay, so now I plug in 0, 4 here, so I'm going to get 4 equals 0 plus d. Okay, so d is 4. When I plug in the 1, 7, I'm going to get 7 equals 2 times 1 plus c times 1 plus d. Okay, so that means that I get 7 equals 2 plus c plus d. Now I want you to look at this. We have two equations, and this one worked out nicely because one of them just gave you d, but this is just a system of equations like you saw back in Algebra 1. Anyway, once you know this d value, which you know here you can plug in, so that just gives you 7 equals 6 plus c, so my c is 1. And then I know the c and the d, so that lets me go ahead, that lets me write my final equation out. F is 2x cubed plus 1x plus 4. So I just have to use both conditions. Anyway, that's how you do these problems, guys. You just have to plug in these values for f, and when you have the f values, you plug in both. When you have the f and the f prime, you just plug them in one at a time right there. Okay, so that's these problems. Just the idea of plugging a point to find the c. Other than that, we're just doing antiderivatives. All right, I'll see you guys soon. Thanks for watching.